Good evening. Welcome to the QCIS channel. Where on this channel, you get a daily dose of science, technology, engineering, and math. And what I'm going to talk about this evening is basically a sequel to what I talked about last week. If we looked at last week's video, I talked about microsurfacing. And microsurfacing is basically a cementitious asphalt mix that you would use for not construction, but for maintenance. And it's good for wheel rutting. Gives you a 6 to 8 year span before you have to go out there and either repave it or reconstruct the road, and it is cost effective. Now, I'm going to talk about today something for bridge decks. In fact, I worked on a project. If you live in a Lebanon area of Indiana, go check out State Route 32. If you go west, we did a bridge. And if you go east of 39, did two bridges. And you also see them on 65. And the contractor that actually does the work on these bridges is Blakely, and they do a good job. And what they do is they put down what we're going to talk about today, concrete polymer for bridge decks. It's a two-coat system followed by a material that is mixed with stone. You have to let it dry, give it about 24 to 48 hours before you can put traffic on it. But it is good material. You have warranted and unwarranted. Basically, the unwarranted is where you have the expansion joints, and the warranted is when you're actually doing the bridge decks. The expansion joints, I call them the approaches to the bridge decks. And of course, when you pay for this material, it's paid for in the square yards, just like microsurfacing is. Now, again, the material, is it new? Other DOTs use it. New York uses it. No, WashDOT, which is Washington Department of Transportation, Utah uses it. The bottom line, it's a cost-effective way to maintain all of your bridge decks. See, we talk about construction, but once the facility is built, you have to be able to maintain it. And it's not constructing it that can be difficult, or it could be difficult if you run into environmental problems or soil problems. But let's just use the assumption that everything is good to go. You have good base, you have stone, everything is good. So when you construct a bridge, yeah, it looks nice. But you know, bridges do age. From the time you construct that bridge, once you put traffic on it, and even you don't put traffic on it, well, that bridge begins to age. So what do you do when it ages? You have to maintain it. Maintenance can be the hardest part because that bridge is going through 4 seasons. And that depends on where you live. Now, I'm going to share my screen, and I'm going to talk about polymer overlays. Now, when first exposed to polymer bridge deck overlays, owners and designers often think one of two ways. There are so many, how do I decide? Well, polymers are all the same. Yes, there are different types of polymer overlays, So basic understanding of the of the different types, basic understanding of the different types of polymers and where and how they can be expected to succeed, that can help lead to more overall success. So as for the other perception, polymer overlays are not the same, and treating them as such will not lead to a quality outcome. Now, what you have to understand is there are basically three major types of polymer bridge deck overlays that are utilized in the US. You have the multi-layer, you have the thin layer, slurry, and premixed polymer overlays. Now, here in Indiana, we use the thin layer. Now, the most successful examples of various types have something in common. They were specified in the location and application that was appropriate for each. So, in the future, once more research is conducted, there'll be more in-depth information into the details of what makes some of these overlays work best. So we're going to have to utilize some more locations now, but what I'm going to do is provide an overview of the attributes of polymer overlays that can be specified. So, multi-layer thin polymer overlays, that's TPO. Well, TPOs consist of two layers of polymer binder, that's polymer binder. And this is what we used on the SR32 job. Again, TPOs, which is a thin polymer overlay, it consists of two layers of polymer binder and broadcast aggregate. Again, that's polymer binder and broadcast aggregate. Now, the typical thickness after application of both layers is roughly 3/8 of an inch. Now, these can be used to protect the underlying substrate deck, and it can increase skid resistance. Now, the most common binder resin for TPOs is epoxy. However, there are other options, including polymer binder resin, let's call it resin, which is basically used for bridge decks, and a company called KBP MLS. That's their product. Now, epoxies can be changed through formulation to achieve desired properties, such as adding a urethane modifier, but the final properties of the overlay system remain similar. And this is how it's being laid right now. That's the slurry that they're placing. Now, the overlays are easy to apply and can be either hand applied by mixing resin in buckets, distribution with squeegees, and hand broadcasting the aggregate, or they can be machine applied using fully mechanized self-contained installation vehicles. Now, a hybrid installation method involves plural component, binder, resin, pumping, which involves a squeegee distribution and pneumatic blowing of the aggregate. Now, on the State Route 32 job, that's exactly what we did. The contractor placed two coats like slurry material, and then they took a pneumatic tool. And what they did, they back and forth. They blew the aggregate onto the bridge deck, and they did it twice. You have to put two coats down. Now, when you do that, the materials tend to be impartial to the installation method. However, there can be a savings in installation costs for large-scale projects when the more mechanized approaches are used. Again, A hybrid installation, that method involves plural component binder rising. That's rising, not rising. It involves plural component binder rising, resin, pumping, which still involves squeegee distribution and pneumatic blowing of the aggregate. Again, the materials tend to be impartial to the installation method, and you can have a savings in installation costs for large scale projects when more mechanized approaches are used. Now, with this installation, cure times can be relatively fast, especially when it comes to warmer conditions. Now, during cold weather, they tend to take a little longer to cure, or they cannot be applied at all. But most summer construction season temperatures are well suited to the typical rises used for these overlays. So ideally, both layers of a TPO, which if we want to go back and find out what a TPO is, that's a thin polymer overlay. Thin polymer overlay. Now, when we deal with the TPOs, the installation should be completed before opening the bridge deck surface to traffic. This means this process requires 2 waiting periods for cure time prior to completion. But in warmer conditions, this can still be completed with a single shift for a typical size bridge. Now, the mechanized operations can make both layers feasible in a shift for large scale installations. Now, like all polymer systems and most other construction materials like concrete or asphalt, these overlays cannot be placed in the rain. Again, they cannot be placed in the rain. In fact, before even putting anything on the deck should be cleaned of all debris. And the deck should be dry. Again, they should be placed on clean, dry substrate, or let's say a dry deck. Shot blasting is the most common means of cleaning a bridge deck to prepare for a TPO installation. Now, again, the service life of a TPO varies greatly and can be extended significantly by specifying within certain very critical parameters that I'll discuss later on. But right now, when it comes to TPOs, generally it'll give you a lifespan of 3 to 10 years, depending on the conditions of the structure, traffic, and environment. Some have lasted longer when the conditions lend well to the system or through maintenance and partial replacement as needed. Now, let's get into a little description of some of the polymers. Well, you have your slurry polymer overlay. Not really widely used in the US, but still seen at times. Slurry polymer overlays are typically about 1/2 to 5/8 inches thick, applied in multiple steps. Typically, the binder resin is methyl metacrylate, which is MMA, and MMA slurries can be mixed with buckets, with a drill mixer, or a large batch mixer. Grade is often established through gauge rake distribution to a single uniform thickness. The final step is the application of a final coat of resin to seal the surface friction aggregate. Again, resin, that's how I pronounce it. MMA slurries can cure very quickly and can be placed even in cold temperatures below freezing. Now, I don't recommend that. And also, though the material itself cures rapidly, there are 3 distinct steps. You have your primer, slurry, and top coat that each require a waiting period for their sufficient cure. Now, the service life of MMA slurry overlay is not as widely documented as it is for the other overlay options. This may be a function of their limited use, and it is affected by the same factors that can help or hurt TPOs. Now, I'm sure any responsible supplier of MMA slurry would be glad to offer some guidance on the subject since they deal with this material quite frequently. Then you have your premixed polymer overlays, PPOs. Now they're made up of a graded aggregate and resin binder. They're mixed on site prior to placement, much like traditional concrete, but include no cement or water. This overlay can be used to protect the underlying substrate deck and provide a wearing surface. Unlike the TPO, slurry overlays grade on a structure can be maintained or changed using a premixed overlay. These overlays are placed to propose grade using forming or slip forming finishing similarly to traditional concrete. Thickness minimum and maximum can vary for different premixed systems. Epoxy, binder, resins or resins have been used for premixed overlays periodically throughout the past few decades, but tend to fail out of favor due to early surface abrasion and incompatibility with the substrate concrete. The most common premixed overlay available currently is quick bond polymers. That's PPC 1121 polymer or polyester polymer concrete, which features a polyester binder resin or resin. Now, the system can be placed at any thickness from 3/4 inches and up. Grade correction through variable thickness placement and any placements of appreciable thickness are common for the PPC 1121 system, but should only be attempted with materials that are formulated for the application and have a proven record of success. See, premixed overlays can be textured to suit the needs of the structure and location. So basically, when the system features a well-controlled resin or resin content, the overlay can be mechanically saw cut, grooved, or spring steel tine. Now, does anybody know what tining is? Tining is generally on a bid well. Tining is the grooving or the roughness that's provided on a bridge deck to prevent slippage. Because if concrete is very smooth, water gets in it, the bridge is going to be slippery. That's why you see signs that say road surface freezes before bridge, because it's uniformly tined. And see, some people, and I'll get into what tining is in the future as well. Now, again, when the system features a well-controlled resin content, the overlay can be mechanically saw, cut, grooved, or spring steel tine and achieve very high skid resistance and wear resistance for the lift of the surface. Diamond grinding is also an option for these overlays. Now, cure time of the premixed polymer overlays varies based on the binder resin or resin. Now, the polyester binder resin in PPC 1121 is controllable and rapid curing, able to return traffic 2 hours after placement in allowable conditions. So typical overlay conditions for PPC 1121 include temperatures between 40 and 100 degrees Fahrenheit. Patching and joint header installations can be placed in a much wider range of temperatures while still returning traffic in 2 hours. Now, because the properties of different premixed overlays can vary greatly, so does the anticipated service life. Now, the expectation of a new or experimental system should not be assumed based on the history of another. Now, the PPC 1121 system has been in use for over 30 years, with near zero installations reaching the end of their functional life or requiring significant maintenance. Now, the most conservative anticipated service life for this overlay is the hardest conditions that would be 20 years. However, in most cases, it would last longer, and a reasonable service life is based on history would be 30 years. Now, in summary, I'll say this, you can see what it looks like. And I'll get into some videos to actually show you how the process works. Now, polymer bridge deck overlays are easy to specify, readily available, and have ample history to show their successes. When specified in the right conditions for the chosen style of overlay, they can achieve their anticipated service life. So a basic understanding of the conditions and issues can help a designer to select the right solution for the needs of a given structure. And again, in the future, we'll get more into the considerations to achieve success with each type of polymer overlay, and I'll do a little more research. But in the meantime, just want you to know that this information is going to be posted under my video description. Look for it, because there are contractors. This one's from Quick Bond Polymers, because overlaying, it's not construction, but it's maintenance, just like microservicing. And what I'm going to do, I'm going to go ahead and I'm going to get into a few videos here. Okay, let me turn up my sound, and we're going to look at a few of them right now. Fair use. This is for educational purposes only. Fair use.
We're here today on Route 94 near Portland, Missouri, where we're assisting a customer with a 2-layer epoxy polymer bridge deck overlay. Some of the issues commonly faced by contractors revolve around the pump systems that are currently on the market. These pumps can be high maintenance items, have a low rate of output, and don't always provide the proper mixing of the resin systems. Today we're introducing our new epoxy polymer pump system. This system is superior to anything that's on the market today by providing a higher capacity output, 2 to 3 times greater than what's currently available on the market, giving the contractor added efficiency on the job and more dollars in their pocket. It's also a lower maintenance type pump, has a computer readout that will give the contractor confidence that we're getting consistent ratio of A and B resins at all times, and provides consistent quality with no variation. This system assures top quality installations for contractors and, more importantly, for their customers.
See right there, we're using the pump system, and you saw the slurry they were placing, and then they were utilizing the squeegee method. That's how to spread it evenly. Now they put 2 coats of that polymer on it. Let's watch another one. Fair use. This is actually from the same company. This is how it is made before it goes out to the site or produced. Fair use.
We're here today in Franklin County, Missouri, where we just installed our hybrid polymer concrete as a bridge deck overlay on Route Y for the Missouri DOT. The hybrid polymer concrete is a unique material. It's strong like concrete, but flexible like asphalt. It'll carry heavy loads, but also has a high degree of flexibility. It will move with the materials that it's bonded to, whether that's concrete or asphalt. It has excellent bond strength. It's also an impermeable material, so that protects the rest of the underlying bridge from de-icing salts and other chemicals that cause deterioration of our bridges. We expect this bridge to have many more years of service, and the overlay itself we expect to last at least 30 years. We also utilized our specially engineered and designed volumetric mixer to produce the hybrid polymer concrete today. It's a 2-part resin system, and we get a consistent mix at all times. We also have a specially designed and built paving machine that can put hybrid polymer concrete down from a 1/2 inch overlay up to 12 inches if necessary. This material allows for the addition of a friction aggregate on top for added safety, provide not only a nice ride surface but also a safe surface.
Now with this one, they didn't even use a pump system. I mean, just like the microsurfacing, you saw how they were mixing it. Like I said, they were using a paver. And again, just as I told you in the article, 30 years. They can place it up to 12 inches. Let me get another one for you. And this is from Quickcrete from NJ Dot. This right here is the tiny. That rate, that's the tiny. That's what tiny looks like. And just so you know, here's some contractors that do it, like Quick Bond Polymers. In fact, that's where this information is actually coming from. You need to know your contractors. Um, Basically, you saw different applications on how it's applied. Now, the last two here in Indiana, we don't use. They generally, like I said, sweep off the bridge. Because I know when I inspect it, I'll make sure that the bridge surface is totally free of all debris. And another thing that you should watch out for when they're placing the polymer is the right traffic control. Now, I am not a fan of working without some type of barrier. They use tubular channeling devices. If a car were to run through that work zone, it would injure or take out one of the construction workers. It's another thing when you are doing work on the roads, you need to utilize proper traffic control. In fact, what they should have done was should have had a taper. If you don't have flaggers, in fact, you don't even need flaggers. What you need to install traffic signals, portable traffic signals. Why? Because you still have to give time for this polymer to set up. But there you saw how it's produced here in the videos. You saw the wand, how they utilize the wand or the pump, rake it out. See, the first video, they didn't use tining at all. The last one, they used a tining. Well, depending on where you are. Now, two different DOTs. The last one was New Jersey Department of Transportation, and the first two were Missouri Department of Transportation. And of course, different DOTs have different specifications. Now, again, when you are paying for this material, you're paying by the square yards, and the material is either warranted or unwarranted. So you have to also make sure that the equipment, before you put anything down, the equipment meets the specifications. You have to look at the computer. A lot of information we don't see when we're inspecting it, but when you get down into the depth of all the details, make sure your equipment is working properly. Make sure that you have the crew that is certified or qualified to perform this process, because you want a good product and you want to get traffic on this product. Now, depending on when you need the bridge to open, I always say wait about 24 to 48 hours, because you have to wait it set. And if you have to wait for it to set, you can put traffic on it after 2 hours. I prefer waiting 24 to 48 hours, like I said, and do one lane at a time. That's what you have to do. But basically, if it's applied right, you give your roads a longer lasting life, and there's less maintenance that has to be performed. Now, again, watch your temperatures, 40 to 100 degrees Fahrenheit. Know that we're in America. We always use the Fahrenheit scale. Now, Canada, Europe, they're on the centigrade or the Celsius scale. And always check your specifications, collect your tickets when you're an inspector, and look at how the material is being paid. And if you're inspecting it, document the minimum materials and how much they place and where do they place it. Make sure you have a reference marker or a station, because this is very crucial. Because if you look at your contract. A lot of these contracts are unit cost. So you're going to have some length, which is linear feet, some area, which is square feet, square yards. And then if we get into excavation, we have cubic feet or cubic yards. And you can include concrete with cubic yards as well. Everything is in the ticket, but again, when you utilize polymer, it's a cementitious material as well. And here in Indiana, we use a two-coat system because you have to let the slurry settle. The slurry is an adhesive, and then you apply 2 coats of the polymer and give it time to dry. And you can also stripe it. Again, do 1 lane at a time. But that's it for this topic, concrete polymers. And again, this polymer is a cost-effective procedure, and it enhances the life of bridges. So you won't have to, your state DOT, you don't have to spend money to actually reconstruct any bridges. But the polymer only works when you look at the structure, because if the structure is deteriorating, no need to put polymer on it. You just have to reconstruct the bridge. But for bridges that have a little wear, the polymer can work, and it is skid resistant or skid resistant. And again, it's the rising or slurry. You have premixed, you have thin. You have 3 ways of putting it now. But again, I'll leave the information under the description of the video. And that concludes this topic again on concrete polymers for bridge decks. If you like what I just presented, please comment, share, and subscribe. And if you're looking for some political or some scam content or social content, check out my main channel, the 411 Talk Zone radio show. Now, after I record my videos on both channels, I upload the videos to my Twitter page. Now, since the QCIS channel is a educational channel, or we say it's an educational channel, proper grammar, then I also upload the information to my LinkedIn page. And once again, you all are viewing this content, make sure you share the videos, make sure you like, share, and subscribe as well. This information, I do my research. It's very good information, especially if you are in the construction industry. And again, thank you for tuning in to the QCIS channel. We're on this channel. You get a daily dose of science, technology, engineering, and math. Until next time, my name is Leon Jones. I want you all to have a wonderful and gracious evening. Happy Independence Day.